So in summary, what are the key takeaways? Well, first, net suppression happens mainly because of misspecified models. So we're leaving out an important covariate or predictor, and our context doesn't have the full, we don't have the full knowledge of the causal chain in our context, as we just saw from the firefighter example. The second thing to think about, just don't be surprised if an additional relevant predictor is added to your equation. So you have this regression analysis you're running and you're adding a predictor. The original predictor's B weights may become significant. Okay, so we may have a classical suppression case where, remember, we saw a much bigger beta weight than we had a bivariate. Or they may flip signs. In the net suppression case, we may have the sign flippage. And compared to their bivariate correlations with the DV, the B weights may show these different signs. Also remember that classical suppression is solely a result of the way the beta formula is set up and the assumptions behind it. Okay, so in the beta formula we can't specify that the shared variance in the predictors is also not shared in the DV. And so since we can't do that, we can't trust beta weights in the classical suppression case. And finally, if you suspect that suppression might be occurring in your data, simply compare the B weights to your bivariate correlations, your zero orders. Revisit your theory to make sure you're accounting for relevant third variables. Remember, those things are like number of times that the batter was facing a difficult pitcher, a challenging situation. Look at the the jobs that minorities are applying to versus the majority group. Okay, so are they disproportionately applying to a certain kind of job? And if you see that, you will know that there is suppression occurring, or this Simpson's paradox that is happening. The competitiveness of the psychology program. It's another case of net suppression. We need to keep that in mind when we are trying to evaluate the selection fairness for those programs. And finally, the severity of the fire. That's a big IV that's causing this whole chain that was left out, and therefore causing us to draw wrong inferences about the relationship between the number of firefighters sent and then the fire damage later on. So those are some helpful tips. Keep those in mind. Just keep thinking about just how these interrelationships play out and different scenarios. I would say that the last one is probably the most important, is you'll know when classical suppression is occurring when your beta weights are vastly different from your bivariates, or they're flipping signs in the case of net suppression. Those are the kind of indicators that you would that would send up a little flag for you to know that suppression is happening.